So here's the first example for two vectors, 11 units south and 6 units west. So before we add them, we have to be familiar with the coordinate system. So this is the Cartesian plane with 4 quadrants. The first quadrant is present on this side. It's here with positive x and positive y. The next quadrant, quadrant 2, is located in the negative x and positive y. Quadrant 3 is located in this side with negative x and y, negative y. And the fourth quadrant is having positive x and negative y. So how do we represent that in a graph? So make sure you scale first. Okay, given 11 units, you cannot represent everything if it cannot fit in our paper. So make sure you scale or provide a legend. So for 1 unit in this example, it's equivalent to 0.5 centimeters. Let's say we already had 11 units south and represented by a vector A. That's 11 units. And then 6 units to the west. Now, what arrow represents the sum of these vectors? This is actually the red arrow represents the sum of the two vectors, and we call that the resultant vector. Resultant vector forming an angle, okay, from the origin. So using Pythagorean theorem or theory, okay, we can actually calculate the resultant by getting the square root of the square, sum of the squares of the sides. So that's 6 squared, that's the side for the B vector, and 11 squared for the length of the vector A. So 6 squared plus 11 squared, square root of that is 12.53 units. And that's our resultant for this example. And in getting the angle, you just have to get the arc tangent or shift tangent in your calculator by dividing 6 and 11. So 6 divided by 11, get the arc tangent, then you will get the angle 28.61 degrees. So in doing such, we have identified our resultant and its location. So 12.53 units, 28.61 or 29 degrees west of south. Now here's another example. Let's say you have already scaled that in your graphing paper. In my case, I would like to have it as 100 unit per 0.5 centimeter. So it's heading westward, 500 units represented by vector A, or that A letter as our first vector. And the other one, okay, after that motion, it headed rather to the north with 400 units represented by vector B. Of course, our resultant is okay, the head of that resultant is touching the head of the second vector. So why is it called the head to tail method? Because the head of the first vector, okay, points to the tail of the next vector, and the resultant vector is actually pointing to the head of the last vector. Okay, so how do you compute for the R? You just have to square 400 and 500, square root the answer, and you will get 640.31 units. And the location, divide 400 with 500 and get the arc tangent. And the result is 38.66 degrees. So the final answer is 640.31 units, 38.66 or 39 degrees north of west. Okay. For our next example, you may do this also, or you may pause the video and do this in your graphing paper. Okay, once you're finished, now let's show the answer. So 7.5 units north. Let's say you have scaled in the graphing paper, 1 unit is 2.5 cm. That's our vector A, or the first vector. Now the next vector is heading to the east. As you will notice, the head of the first vector touches the tail of the next vector. To represent our resultant vector, then you will notice here an arrow with an arrowhead touching the arrowhead of the last vector or the second vector. So how do you compute that? Get the squares or the sum of the squares of the sides, 3.5 and 7.5. Get the square root and you will arrive to this answer, 8.28 units. And to get the angle, then you have to get the quotient of 3.5 and 7.5. Get the arctangent and you will see the answer, 25.02 degrees. And our final answer is 8.28 units, 25.02 degrees east of north. Now for our last example, you have here 7 units east and 12 units south. So let's represent that with an arrow in our first vector, and the second vector is 12 units south. Okay, represented by vector B. Okay, to represent our resultant vector, then you will notice here a red arrow pointing to the arrowhead of the last vector. Okay, using Pythagorean theorem, you will just square or sum of the squares of the side, 7 squared and 12 squared, get a square root, and you will have this result, 13.89 units. To get the angle, have the quotient of 7 and 12, get the arctangent in your calculator, and you will see the answer, 30.26 or 30 degrees. Now, the problem here is the location. Yeah, that's the answer, but you can just flip it if you are confused. Okay, you can flip it, okay, to get the answer. So I cannot anymore move backwards with this application. So that was the answer for the previous example. So let's review about the different angles. Okay, let's take note that if you notice this, okay, the angle is formed between this arrow or the given arrow and the positive x-axis. Then you call that the north of east. If it's formed between the positive y and with your arrow, then we call that the east of north. If it's formed between the negative x and that arrow, then it's called the north of west. If it's formed between the positive y and that arrow, west of north, and so on. So if it's formed below the negative x, that is the south of west. If it's there, then west of south, formed between the negative y and that arrow, negative y and this arrow, between them is an angle. Okay, east of south, and lastly, okay, just below the positive x, but located near negative y, then that's the south of east. So you have to be familiar with all those so that you know how to express the final answer when you're asked of the location of a certain vector, especially the resultant. So here's an example for 3 vectors. Let's say, okay, vector A is 25 meters, 49 degrees north of east. So of course you know that north of east is in the side. So you have to use the protractor to identify 49 degrees. So when you're done using your protractor, then you measure 25 meter using a scale. Let's say your 1 meter is 0.5 centimeter in your graph. So you will have this kind of answer. So that's our vector A, 25 meter, 49 degrees from the x-axis. And then the next part, okay, to represent our vector B, you may represent another Cartesian plane here at the arrowhead of the first vector, touching the tail of the next vector. And you will notice here that it's 15 degrees north of east. So from the horizontal line, 15 degrees coming from positive x, okay, that side, and you draw after identifying the angle. So that's our letter B or vector B. Our vector C, obviously you have to draw that by identifying first where to draw the next Cartesian plane, small Cartesian plane. Of course, it's in the arrowhead of the second vector. There. and then use a protractor to identify 68 degrees south of east. Now 68 degrees south of east is here on the fourth quadrant. Once you're done measuring the angle, then you start drawing the arrow downwards that exceeds the horizontal or x-axis. Of course, how are you going to identify the resultant? It's by drawing an arrow from the origin going to the last or the arrowhead of the last vector. Okay, that one. So you can do that by measuring this with your ruler and identifying the angle between the x and this arrow resultant using a protractor. Okay, the answer to that is 50 meters, 7 degrees south of the east. Okay, here's another example. 5 kilometers west, so it's already drawn, 5 kilometer west. Okay, there's no angle, therefore it should be along the x-axis. Then after moving in such manner, it has moved also, or the next vector is heading northward. Okay, with no angle or no inclination, so it's northward. And the next vector is actually connected to our second vector, so you have to represent another Cartesian plane so that you will know where to measure using your protractor. So what's 345 degrees? Take note, in the first quadrant is 90, second quadrant has also 90, all in all that's 180. And for the third, 180 plus 90, we have 270. And of course, the entire thing is 360 degrees. So you will locate 345 degrees in the fourth quadrant because it's close to 360 degrees. So you will notice here that the arrow has been drawn in the fourth quadrant. Okay, with this length 3.5 kilometers. Now, to draw the resultant coming from the origin going to the head or arrowhead of the last vector. So when measured, that's 2.3 kilometers, 135 degrees CCW. CCW stands for counterclockwise. So meaning the angle is measured from the positive x going to that location. Okay, so let's review on unit circle because you've noticed I have mentioned counterclockwise and clockwise. So this is what I'm talking about. I've already mentioned about the quadrants 1, 2, 3, and 4. In the first quadrant, we have a 90 degrees in total from the x, positive x, going to the positive y. Next, of course, is another 90 in the negative x and positive y. So all in all, on the upper part, we have 180 degrees. And let's add another 90. Okay, in the lower part in the third quadrant, so 90 plus 180 results to 270 degrees. And lastly, we have 360. Okay, now if there's an arrow drawn in that location, it intersects, okay, that circle at one point. So it has an x component and a y component. So you have to review your trigonometric discussions before about unit circle, okay, if you want to learn more about this. Okay, and also we have to review about the trigonometric functions, especially the definition of SOHCAHTOA. So SOH, sine theta, is equal to the opposite over the hypotenuse of the angle. So this is only true for a right triangle. So this is the right triangle with 90 degrees and angle is here. Okay, so opposite over the hypotenuse. That's the sine theta. Cosine theta is adjacent of that angle divided by the hypotenuse of the triangle. Tangent theta is the opposite of the angle divided by the adjacent leg or adjacent leg of that angle. So that's TOA. So that's how we define SOHCAHTOA. For today, and here are my references. God bless and see you again next session.